Hello students, today's video is on solving absolute value equations. You can solve some absolute value equations using mental math. For instance, you learned that the equation, the absolute value of x equals 8, it has two solutions which are 8 and negative 8, because if you take the absolute value of 8, you get 8, and if you get the absolute value of negative 8, you also get 8. So to solve absolute value equations, you can use the fact that the expression inside the absolute value symbols can be either positive or negative. To solve an absolute value equation, the first thing that you're going to do is you're going to isolate the absolute value part of the equation. Then you are going to set the absolute value expression equal to both the positive and negative solutions and solve it. And the last thing that you must do is you must check your answers, because sometimes you will get some answers that do not work in the original problem. So let's look at this first example. We are going to solve the absolute value of x minus 2 equal to 5. So the first thing that we want to notice is that the absolute value needs to be isolated, and in this particular example it is. So the next thing that we're going to do is we're going to take what's inside the absolute value bars and we're going to set it equal to positive and negative of what it is equal to. So let's take the first part. When x minus 2 is positive, then what we're going to do is we're going to set x minus 2 equal to positive 5. And when we do that, then we would add 2 to both sides, and so x is equal to 7. So when the inside of the bars is positive 5, then x is going to be equal to 7. We're also going to look at what happens when x minus 2 is negative. So x minus 2 is equal to negative 5. We would add 2 to both sides, and that would give us negative 3. So our two solutions are 7 and negative 3, but we also want to make sure that we check our answers. When we plug in 7 to the original equation right here, we have the absolute value of 7 minus 2, which is the absolute value of 5, which is 5, and so that works. Then we also want to plug in the negative 3. When you have the absolute value of negative 3 minus 2, that is the absolute value of negative 5, which is 5 as well, so both of them work. Now let's look at another example. So we have the absolute value of 2x minus 7 minus 5 equals 4. And so the first thing you want to do is make sure that the absolute value expression has been isolated. And right now it has not been isolated. We need to add the 5 to the other side so that we can get the absolute value by itself. So once we do that, we get that the absolute value of 2x minus 7 is equal to 9. And so now what we're going to do is we're going to split it up into setting it equal to positive 9 and setting it equal to negative 9. So for the positive side, we will get 2x minus 7 equals positive 9. You'll add 7 to both sides, you'll get 2x equals 16, and then you'll divide by 2 and get x equals 8. On the negative side, you will still add that 5 over to the other side before you start to set it equal to the negative. And so we have the absolute value of 2x minus 7 equals 9. We're going to set that equal to the negative 9, so 2x minus 7 equals negative 9. You'll add 7 to both sides. You get 2x equals negative 2. Divide by 2, and x equals negative 1. So we have our two solutions, which are 8 and negative 1, but we must check them. So to check our solutions, when I plug in 8, I get 2 times 8, which is 16. 16 minus 7, which is 9. The absolute value of 9 is 9, and 9 minus 5 is equal to 4. And so that is correct. Now we're going to check the other side. So 2 times negative 1 is negative 2. Negative 2 minus 7 is negative 9. The absolute value of negative 9 is 9. 9 minus 5 is 4. So you can see that both of them check. Now let's move on to another example. So we have the absolute value of 9 minus 2x is equal to 10 plus 3x. So if we look at our first step is to isolate the absolute value bars, and you can see that it is already isolated. So then our next step is to set what's inside the absolute value bars equal to positive and negative. So what we're going to do is we're going to take that 9 minus 2x, but we're going to set it equal to the positive, which was 10 plus 3x, and then we're going to negate it and make it negative and then parentheses 10 plus 3x. So you'd have to distribute that. So this is what it's going to look like. When 9 minus 2x is positive, we have 9 minus 2x equals 10 plus 3x. We're going to get our variables together, so we're going to add the 2x to the other side, and that becomes 5x. So then we have 9 equals 10 plus 5x, then we'll subtract 10 to the other side to give us negative 1 equals 5x, then we'll divide by 5, and so x is going to be equal to a negative 1/5. On the negative side, we'll take that 9 minus 2x and we're going to set it equal to the negative of 10 plus 3x, which means we have to distribute that negative 1, so then we'll have negative 10 minus 3x. We're going to get our variables on one side, so we'll add the 3x over here, so we get 9 plus x equals negative 10. Then we're going to subtract 9 over here, and we'll get x equals negative 19. Now, the last step is very important because it says, because now what we have is we have two possible solutions, but we need to check it to make sure that they both work. And so when you see here, negative 19, we call that an extraneous solution because it does not work when you check it. This is what we would get. We would get the absolute value of 9 minus 2 minus 19. That's going to be the absolute value of 9 plus 38, which is the absolute value of 47. On the right side, we have 10 plus 3 times negative 19, which is 10 minus 57, which is going to be negative 47. And the absolute value of 47 does not equal the negative 47, so that is not a solution. So this right here cannot be a solution. It is an extraneous solution, so we're going to mark that out. It cannot work. And so this would be our only solution in this problem. Okay, that is the end of the video. Please answer the questions on the Google form and submit it to me.